All right, now we're going to look into the initial tasks in developing HACCP plans. What does that include? Big one right here. Remember this one. Write this down. Think about it always. When you are talking HACCP, the misconception is that it's all about food safety and quality. It's all about food safety and quality. Where's my food safety and quality manager? What are they going to do? How are they going to get me out of this? What are they? And the reality is, yes, food safety and quality has the bulk of the responsibility when it comes to leading the team, but recognize I'll say it once again, and I'll say it probably 30 more times before, the end of this presentation. Everyone owns food safety. Everyone owns quality. Everyone owns the HACCP plan, right? Upper management must make a commitment to support HACCP, both financially and in spirit. If we do not do that, we do not get upper management buy-in, then HACCP will not exist. It will not function. It will not work. So implement well-designed prerequisite programs first in order to do that. Prerequisite programs provide the foundation for the HACCP system and identify and evaluate existing programs to determine efficiency. So there's 5 initial tasks that we have to do in order to implement the HACCP plan system the right way. One is assembling the HACCP team, which includes the HACCP coordinator, the multidisciplinary a multidisciplinary unit, which that includes, it can't just be food safety and quality. It has to be comprised of logistics and operations and maintenance, all parties, right? Consultants, if necessary. Sometimes you don't need third party to come in and do it, but they help, especially with audits and stuff. Ad hoc groups. So how do I connect and contact everybody if we find out that we've got a big deal and we got to get product on hold? How do we make sure everybody's involved and everybody is aware such that we can execute and minimize the risk as soon as possible, right? If we can't do that efficiently if we don't have some type of ad hoc group, some type of protocol to be able to get that, disseminate that information responsibly. Second one is describe the food and its distribution. So you use common names and ingredients, the nature of the product and the shelf life, the general description of the process, the type of storage and distribution, the parameters related to food safety like the pH, the water activity, packaging, preservatives, etc. Collect the detailed information on the formulation and ingredients. So that includes processing aids, ingredients known to be a source of potential pathogens like salmonella in the poultry and eggs, so forth and so on. And it also includes ingredients with associated potential chemical hazards like antibiotics in milk and nitrate in cured meats. Guys, all this information is super important when you're coming together with this. We've kind of went through some of this stuff piece by piece, and this is just pulling it all together. Describe the list or the intended use of consumers. So is this for retail, food service, further manufacturing, etc.? Because, while it doesn't hold, as much weight as the direct risks of the product themselves, we still need to keep that in mind when we are making big decisions on products and issues. Potential for mishandling, preparation procedures like heat and serve, ready to eat, or reconstitutes. Intended for at-risk individuals like infants and immunocompromised and elderly and stuff like that. Like, gotta understand what those, once again, implications are, so that when we hit product that isn't cut and dry, and we're working in the gray, which we do all the time. Seems like forever we reside in the gray. You need to have those pieces in mind so you can make the right decision. Good decision is an informed one. Develop a flow diagram. So it's a simple block flow diagram showing the locations where the specific ingredients are added and where storage, preparation, and processing steps occur. That's easy enough. And you can refer to those. You're going to have to update those on a regular basis, review those at least yearly. And then the last one is description of product and process. So the block flow diagram should be supplemented with the description of product and process flow. It may include information associated with ingredient storage, preparation, equipment, processing, packaging, storage, and distribution. There's a regulatory requirement as well. Like for instance, FSIS requires a flowchart as part of the hazard analysis for meat and poultry products, including designation of CCPs on the flowchart. We need to know where they are. Don't necessarily need to know where all the CPs are or control points, but everything that's critical needs to be identified. I thought that was the last one. So the last one is verifying the flow diagram. Now that we created it, we've got all the information on there, the CCPs, etc. Now we got to walk it. A flow diagram should be verified for accuracy and completeness on site, on it during an inspection of equipment and operations in the whole facility. And usually that happens as a group and not one-off, not by one person, because everybody's looking at different things. Everybody's looking at the same thing differently, and we need all that information when we're putting together the program. So the summary of the task, again, assemble the HACCP team, describe the food and its distribution, identify the intended use of it and consumers, develop the flow diagram, and then make sure that it's accurate. Any questions? All right, that was quick. So what are the two things that must be certain in order to develop a robust HACCP plan? Hopefully you wrote it down. You got the management team needs to be invested both in spirit and in the pockets. And then the prerequisite programs must be solid. And you are well on your way to a good one after you've developed those or complete those 5 tasks that we just covered. But these two have to happen before you complete those 5 tasks. Finally, we got the hazard analysis, and we're going to probably take a break after this, but we'll see. The hazard analysis is super important. Now we've got all the information. Now we've got completed all the tasks, and we're ready to really take a look at this thing and understand it. We're going through the principles. So the first principle is conduct a hazard analysis. Let's have this definition. We've seen it before, but hopefully you can get it now. So the hazard is a biological, chemical, or physical agent that is responsible, likely, or reasonably likely to cause illness or injury in the absence of its control. A biological, chemical, or physical agent that is reasonably likely to cause illness or injury in the absence of its control. That's a hazard. Hazard analysis is the process of collecting and evaluating information on hazards associated with the food under consideration to decide which are significant and must be addressed in the HACCP plan. 2 stages to the hazard analysis. You got the identification of the hazard, and then you got the evaluation of the hazard. The identification of the hazard is just the list. We list all the potential hazards. Then the second one is based on the severity and likelihood of the occurrence. We evaluate those hazards. Let's take a look at the hazard identification. We review potential hazards. For potential hazards, we review the raw materials or ingredients used in the product, the activities conducted at or around each processing step, the equipment used to make the product, the method of storage and distribution, and then the intended use and consumers of the product itself. Evaluation includes 3 different steps. You got micro contamination, you got chemical contamination, you got decomposition if the food hazard exists. These are all very, very, very important pieces. When it comes to hazards, you got natural toxins, you have unapproved use of food or color additives, you have presence of undeclared ingredients that may be allergens, and then you also have physical hazards. Now, we are evaluating. The first step is to assess the severity. How serious is this? Consider the susceptibility of intended consumers, the impact to secondary problems, the magnitude of duration of the illness and the injury that's involved, right? So what does that mean? if I say the risk is salmon, if we say we're evaluating the hazard of salmonella in egg that we produce, right? And I say, oh, okay, well, we don't necessarily have the COA for this for this egg product. We're receiving it in. My operations manager is telling me that we need to produce this food, or they're gonna get, we need to make this production, and we need to turn over this product, ship it out, or we're gonna lose orders by Walmart. If we lose orders by Walmart, then it's just gonna be bad business. We may risk losing that shelf space. And at the end of the day, the food safety and quality response to that is, respectfully, we're gonna do whatever we can to get that product replaced or the ingredient replaced. What that means is maybe we can't get a hold of the supplier, maybe they can't confirm for us using the COA program, using the certificate of analysis saying that the salmonella is below a certain level. Maybe they can't do that, but that doesn't mean that we can go use this product. Maybe the answer is calling a sister plant or calling the supplier and get them to do a next day delivery of something that's already been confirmed. Either way it goes, it's not worth the risks to go back and use some product that we don't have confirmation from to say that it does not pose a food safety hazard to our consumers. Determining the likelihood of occurrence. So consider the likelihood of potential hazards under existing prerequisite programs, the association of hazards with ingredients and products, the method of preparation in the facility, the conditions during transportation, expected storage conditions, and then lastly, likely preparation steps before actually consuming the food, which is important as well. Lastly, determine if the hazard needs to be addressed in the HACCP plan, eliminating the hazards of low severity and no likelihood of occurrence, including all significant hazards based on severity and likelihood of occurrence, justifying the decisions. And even though it's difficult, it's often a subjective process. Whatever we do, we need to document. Document. Whatever you do, just document it, because even if you're wrong, at least you have it documented. You have your reasons why. You have your support. You have things that you can, move forward with. And, you're not just moving willy-nilly. And it's going to help you along the way. It's going to help the team along the way, figure it out. Documentation is always going to save you or put you in a better place, in my opinion, when you're wrong or when you're not, thinking all the way straight. And some people may say, oh, well, if I didn't have the record, then, I personally don't have that kind of philosophy. Wherever we're going, whatever we decided, the better we document it, the better off we'll be. Hazard reasonably likely to occur. So one for which a prudent processor with established controls, you have to do experience, illness data, and then scientific reports. Reasonable possibility hazard will occur in the absence of controls. So these are the two different categories or two different ways. Essentially, you have to look at hazards and be able to tell, like, okay, once again, this is that gray area you're working with. Even though it's subjective, you just got to make sure that you're documenting, you have your proof, you did your research, you're connecting with folks. Hopefully you have some people that you can lead on within the organization itself to help you make those decisions and talk about it. But you got to do your research, and you got to do what's best for you at the time, and always document. So this is an example. We got 2 steps of form, material, biological in the first step, chemical and biological in the second step. And then you got the likelihood and severity that you rated. So for the form material, they rated low, and severity, they rated medium. So therefore, it wasn't a risk, not a risk. And then because it wasn't a risk, you got to say, what do you do? Well, all raw materials pass through a sifter. So it's not a significant risk there. NS stands for not significant. When you talk about biological, you got the likelihood of it occurring is medium, and then you've got a severity of high, right? So that, once again, we're talking about it. If you run into an issue with salmonella, for instance, right, That's a biological risk. You need to make sure that we're cooking it above 90 degrees Celsius because the risk is significant. And that is now a CCP. If that doesn't happen, then we're in, we're run the risk of potentially causing a food safety hazard, a food safety risk for our. We run the risk of causing food safety event in the future at some point in time if we don't manage that risk appropriately. And so, same thing with the biological and the chemical for step 2. Won't talk about, talk the details. You can see specifically what it's stating, but you have to look at the likelihood and severity of each issue of each hazard and then rate it and then have your follow-up control measure for it. So example 1 is the analysis for egg containing product. Stage 1 is hazard identification. So to determine the potential hazards associated with the product, salmonella in finished product is the hazard that it's been identified in analysis for egg. So step 1, you now assess the severity of health consequences if the potential hazard is not properly controlled. Salmonella in finished product may result in salmonellosis, an infection with moderate to severe consequences. Step 2, what is the likelihood of the occurrence? Product is made with liquid eggs, which have been known to contain salmonella. If not controlled, consumers are likely to be exposed to salmonella. We pretty much just talked about this. Step 3, you decide if it's potential for this hazard to be addressed, or if this hazard needs to be addressed in the plan. And the answer for this particular case is yes. Salmonella from liquid eggs is not properly controlled. Consuming this product presents a significant risk to our consumer, and so we do it. Example 2 is the blending step, right? So we identified the risk, which is residual of sanitizers in the blend tank. So every now and then, well, actually after every batch, you probably need to run it through some kind of wash step that should conclude sanitizers every now and then at least. And so you assess the severity. What's the severity? You got sanitizer residues would be diluted with product, therefore unlikely to have severe public health impact. Step 2, the residual sanitizers are XYZ whatever reference includes a pH check of a final rinse. So, you got the documentation there, and then you're saying, okay, so now that we know this, is it or should it be part of the hazard plan? And we're saying no. The residual sanitizers are not likely to occur and unlikely to pose a health risk there. Now, what about the grinding step for this other one? So this one, you got the hazard is metal from the grinder. After you look at the severity, you're saying, okay, metal fragments generated from grinding are below the 7 millimeter mark and are unlikely to cause severe injury. So evaluation of the metal detector kick out records for the last 2 years, looking at data. Remember, we talked about data is one of the ways that we can prove it out. Shows only 5 metal detector findings over so many million pounds of product. So as a result, no, the metal fragments is not likely to occur and doesn't pose a health risk. The justifications for omitting potential hazards and hazard plan is the NRLTO, which is not reasonably likely to occur, even in the absence of the control at levels likely to cause injury or illness in finished product due to system design and because of a specific SSOP prerequisite program. These are the reasons why, or justifications as to why you can say a hazard is, doesn't need to be in a hazard plan. After identifying hazards, identify how they will be controlled. A control measure is an action or activity to prevent, reduce, or accept levels or acceptable levels. A control measure is any activity or action to prevent or reduce to acceptable levels or eliminate the hazard itself. So some examples are pasteurization, roasting, metal detection, filters, and acidification. Control does not need to occur at the point the hazard first appears, and that's super important because I don't know why, but some people think that, and that's just not true. You can control that hazard later on down the line. Now, you still pose the risk of increasing your risk of, that hazard getting out, whether it's because you have accumulation of byproduct or offal, or product that can be reworked in the system. The longer you have that product that is potentially contaminated in the system running, the higher your chances of reintroducing that product or using that product somewhere down the line. So the best thing is to, control it at the point of the hazard, but it doesn't necessarily have to happen that way, and it usually doesn't go that way. Some examples, you got point of occurrence, you got raw juice, puree, and equipment. With raw juice, you got the vegetative pathogens identified, and control measure is pasteurization. With puree, you got sulfites, and that one is labeling. And lastly, with equipment, you have metal fragments, and we use metal detectors to control that. Some regulatory considerations include the hazard analysis required component. So you've got the USDA, FDA juice hazard regulations require written hazard analysis. The FDA seafood hazard regulation does not. Specific hazards have been identified by the agencies. The agencies require scientific justifications for evaluating hazards. So essentially what this is just talking about is, regulations can be different depending on what you're producing and where you're producing it. And just kind of understanding what the regulations are helps you to protect the food and the consumer of the others, but also protect your company and your organization, and the place that you work. All right, so that was a long one. Now we're going to kind of go into, do the chapter review first. Before we go into specifically the different ways to, or principle 2, it's really what this is. We got principle 1 with identifying the hazards. Principle 2 is a little bit interesting. Hopefully you kind of understand where we're headed, but if not, we will get there pretty soon. Looking at number 1, a thorough hazard analysis is vital to an effective HACCP plan. True or false? Now, all these, the next 4 are all true false statements. So we're going to give you some time to read through them, but that's the first one. What's vital to an effective HACCP plan? Is a thorough analysis vital to that? Number 2, we identify hazards using 2-stage process: hazard identification and hazard evaluation. Number 3, the evaluation of hazards is based on the likelihood of only occurrence. That's it. It's only occurrence. Then number 4, we identify control measures after we've identified hazards to be addressed. Give you a couple more seconds. All right, so number 1, the thorough hazard analysis is vital to an effective HACCP plan. That is true. Number 2, we identify hazards using 2-stage process. That is true. The hazard identification and evaluation, those are the first couple steps towards a great HACCP plan and understanding what your hazards are. You have to identify them, and then after you identify them, evaluate what part of this hazard is important, because once you understand that, then you can move forward and try to control it. The third one, the evaluation of hazards is based on the likelihood of occurrence. We already know, right? It's not just the likelihood. We talked about this. It's not the likelihood only. There's two factors. Likelihood is one of them, but the second one is the severity. How severe is this issue? Is this hazard? Because, severity is very, very important. If it's something that's going to definitely cause death versus something that might cause a little irritation, they're two totally different levels to that, right? And so you got to make sure that you are incorporating that when you identify the hazard and when you're understanding what the hazard is, because that can be the difference between you stopping equipment. That can be the difference between you making in actuality, I think, the more severe hazards are easier to manage because there's less gray area involved in there. If I believe that, my consumer is going to get harmed by this product, then it's an easy, no-go. It's an easy destroy. Now it hurts the pocket. It hurts the end of the quarter results. It hurts our numbers, but it's an easier decision because, we know what the repercussions are. So it's kind of one of those things to think about: likelihood and severity. And lastly, we have to identify the control measures. We do that after we've identified the hazards to be addressed, right? And so obviously that one's true. You have to identify it. You got to evaluate it before you start looking at control measures. All right. Any questions on hazard analysis? Okay, so principle number 2 is determining the critical control points. So now that we've already identified the hazards, we identified them, we evaluated them, we're looking at how we can control it. Now we got to control the critical control points. The critical control points that's the bread and butter of the HACCP plan. You need to understand where they are and what the critical limits are as well within those critical control points. Whenever a critical control point is not working or is not in effect, then essentially you're saying that the product is not, this stands a chance of having a hazard along the line during production where you can't not identify it. You always want to be able to detect when the issue arises. That's what the job of the critical control points are. Therefore, if it's not working, then you probably should be running. So CCPs, or critical control points, are based on the results of the hazard analysis, the piece that we talked about before. They all are significant hazards, and they all have control measures associated with them. Identify one or more of the CCPs to control each significant hazard. So sometimes you have more than one CCP in order to control a significant hazard, and that's just to have multiple lines of defense before you're able to, the potential of that hazard gets out of your control, out of the facility. So before you have critical control points, you have control points, and control points is just any step within the system that biological, chemical, or physical hazards can be controlled, right? So it doesn't necessarily have to be the most important step, but it is a step. It's an indication. So I like to say indication because what happens is, what you'll find is that, for instance, if you're trying to control metal in your system, you have multiple metal detectors throughout the system, depending on how long it is, and how many pieces of equipment that you have to monitor that produce metal on a regular basis. And so you may have a total of 4 metal detectors, but you only got one critical control point, one metal detector that if that fails, then we should not be running. We can't run. We have to shut the line down. Those other 3, if they fail, that does not mean that we have to shut the line down. That just means we may have to, monitor a little bit more closely, and, just be mindful of it. But we don't have to shut the line down as a result because it's not a critical control point at that time. So a critical control point, this is the formal definition. It's a step at which the control measure can be applied and is essential to prevent or eliminate a food safety hazard or reduce it to an acceptable level. So this is kind of what I was just talking about. So there are many control points in a process, but only those points essential for production of safe food are considered critical control points, or CCPs. So now we're going to go through a list of examples. So here we have the hazard is salmonella, and it's with raw vegetables, right? So say you got salmonella as a hazard with your raw vegetables. How do you control that? Well, we can control that through the supplier guarantee. So basically, how do we guarantee the product that we receive before it even makes it to the production line in our facility is safe, right? So there's documentation that we are getting from our suppliers to say that it's safe, and that's what that is. Then we got refrigerated storage. So we're making sure that the raw vegetables are stored in the temperatures that they should be stored optimally, right? We're not, we're not encouraging growth of the salmonella by storing it in the area that that promotes that. Remember, we're kind of talking about our hazards themselves. We understand the limits of temperature that salmonella can grow. So what we'll do is just make sure that we don't store it in those temperatures, right? So that's how we manage that. And then sanitary environment. We have a frequency using our MSS program, or master sanitation schedule, that detects or determines how often we're cleaning, what we're cleaning, the chemicals that we're using, etc. And then the last one is heat treatment. So now even further down the line, after the product has already made it on the production line, how do we, use heat as one of the control measures because of the hazard salmonella? We know that heat is a control measure. Let's go ahead and use that in our system to once again reduce the amount of salmonella presence. So the last piece here is the CCP. That's that heat treatment, which means that we can do all those other things, but if we don't have that heat treatment, then we're not necessarily protecting against this hazard the way that we actually should, right? This heat treatment is the critical control point. It's the very most important piece. We don't do that, then we're shutting down the line until we can. So we have to do that actually for all of our hazards. We have to determine what is the critical control point for all of the hazards that we've identified on our system. Each identified hazard has at least one CCP. Once again, we can have more than one, but we have to have at least one CCP. There's more than one control measure that may be needed to address the hazard, right? And then more than one hazard may be controlled with a control measure. So my heat treatment could be taking care of salmonella on one hand, but it also could be taking care of listeria, or it also could be taking care of fill in the blank of, one of the biological hazards, right? It does that and you have to have it listed in your hazard analysis that basically states what is this CCP taking care of. Once again, because if in fact something happens to this, and Murphy's Law says that at some point you will have, an oven that goes out. What is our justification to operations to say we can't run this line, right? They're using you. We need you as a subject matter expert in food safety and quality to say, yep, I know we need to, meet this quota. I know we have Walmart orders that are due tomorrow night, but we can't run tonight until this heat, this oven is fixed, right? And here's the proof. Here's the justification. This oven makes sure that we don't have, for instance, salmonella in our product. So here are the important considerations here. So use the output of the hazard analysis. Basically, do not base the CCPs on where there are controls. So once again, that's why this hazard analysis is so very important. It's also a working document because things change within your product, things change within your system itself. You always got to use this hazard analysis and use that as a foundation of the decisions that you make further down the line. A subsequent step in the process may be more effective for controlling the hazard. So understand that, when you're defining your CCPs, you have to look at the system as a whole. That's what this is basically saying. At some point in time, you got to make a decision, but further down the line is always at some point, easier to control, because although you have a lot of space in between maybe where the hazard is introduced to the line, if you do it further down the line, you have a better chance of making sure that hazard does not get out the door. So here's so what is the CCP decision tree? CCP decision tree is a tool to help determine the appropriate CCPs that are identified within a system. So these different organizations, they have examples of this. They do not apply to all potential hazards. They only, usually apply to these CCPs. Once again, it helps you to make a decision. That's what it says. It's a decision tree. It's an easy way to make a decision without having to use that kind of brain energy and brain power when something comes up. Now you can, rely on documentation in order to make that decision. There's so many other things that happens when a hazard comes about. There's so many things that happens when you are managing a hazard, like logistics, potentially shipping product out the door. You don't want to, exacerbate the issue. So the CCP decision tree helps you to make that decision based on foundational understanding of the hazard analysis, while using your other energy, your brain power, majority of that communicating to the necessary parties to make sure that you're wrapping your arms around the hazard such that it doesn't become an even bigger issue. So that's what the decision tree is for. It helps you to determine what you should be doing when an issue arises. So here's an example of one. And as you can see, I won't go through every single line, but the questions here is what I'll go through. And it's a simple yes or no. Do control measures exist at this step or subsequent steps for the identified hazard? This helps you to define, yes, is it a critical control point, or is it not a critical control point, right? So if the answer is yes, then you go to number 2. Number 2 says, does this step eliminate or reduce the likelihood of a hazard to an acceptable level? If the answer is yes, then it's automatically a critical control point, right? But if the answer is no, you go to number 3. Number 3 says, could the contamination of the identified hazards occur in excess of acceptable levels, or could these increase to unacceptable levels? The answer is yes, you keep on going, right? And so you keep on going, you ask yourself these questions till you get to the bottom end. Either it's a critical control point or it's not one, right? So this helps you to define that. So question 1, does this step involve a hazard of sufficient likelihood of occurrence and severity to warrant its control? Number 2, does the control measure for the hazard exist at this step? Number 3, is the control at this step necessary to prevent, eliminate, or reduce the risk of the hazard to consumers? So those are the questions. And now you're kind of looking at, okay, how do we designate the CCPs? And these are kind of like identifier numbers, right? Like you can't just say, oh, the CCP went out. You got to say which one it was, or have some kind of, some kind of identification. How do you designate the difference, determine the difference between the CCPs? So you got different ways to do it. You've seen it as different examples and multiple examples. You can use those two organizations with the examples that they have on their websites. This is some examples here, but you got to make sure you're differentiating the two, or all the CCPs, because on the document you don't want to call out this super long name. You can say CCP1, CCP2, CCP oven, right, packaging, but you don't want to have this elaborate name that people won't really understand. Just designate, some kind of, got to have an identifier. And so this is one of the ways to do that. So how many CCPs should we have? Well, it really depends. It depends on the hazards, the number of hazards you have. Once again, go back to the hazard analysis. It will tell you about the type of product, the ingredients that we have, the processing methods, the existing prerequisite programs, the regulatory concerns or issues. There's so many things that are involved in having and answering that question. Sometimes CCPs get added, sometimes they get removed. I would say most importantly, look at the hazard analysis, make sure that it's a team effort, and then lastly, you know, recognizing that things get added and subtracted all the time. It's a living document. So document. Whenever you make a change to your hazard analysis, it should be documented. And I would suggest that it's documented in more places than one. Wherever you can document that change, I would say is most important. And then communicating with your HACCP team such that everybody's on the same page. Because it's not, I'll say it over and over again throughout this training, is that I think over the years as I've gone through, and being a leader in food safety and quality, it's so much less about being right the first time than it is about when you figure out that you were wrong, you are documenting and you are fixing it. You don't have to be right the first time. The wrong thing to do is to not be right and not document it and not correct it. That's so much more important than being right. So if you do that throughout the entire process while you're building your hazard analysis, you're building your HACCP team, you're building the HACCP plan, you will be in a much better spot trying to, make sure that you're documenting things and you're using your team. And, when you are wrong, you have corrective actions and preventive actions on that. Then you trying to be right the first time and then sweeping stuff under the rug and not necessarily, and you might not even be sweeping stuff under the rug, but if you don't document it, then how can you prove that it happened? Right? So you got to find some way to document everything that you do, all the changes that you make, such that when you are gone, you want it's a system. When you're not there, the system still has to operate. The plant system has to operate. Got to make food safely, right? And so that's the methodology or the philosophy behind, why you should be documenting everything. So we just covered this last one. Each hazard has at least one CCP per government regulations, and the CCP decision tree is simply a tool used to determine the appropriate CCPs in your system. It helps you to say, yes, this is a CCP, or no, actually, we don't need a CCP, or no, this is not one. So definitely, need to utilize those the CCP decision tree to make sure that you're understanding what your true hazards are and you're addressing or you're operating each one of the control points appropriately, because sometimes you will denote a control point in the system as a CCP and it really isn't, and it can work against you because now you're holding it to a higher standard, which means that if things go awry and things happen in the system that not supposed to happen, or you run into some maintenance issues or what have you, if it's not working, then you have to shut the system down. You can't run without a functioning CCP, especially if that's the only CCP pertaining to that hazard on the system. So be mindful of how you're denoting and the control points on your system. Otherwise, you can run into some issues. So the next section we're getting into is critical limits. So this is HACCP principle number 3. How do we establish the critical limits? Now that we've identified the hazards, we know what the control measures are for the hazards. Now we got the CCPs to control them. Now that we have established which CCPs or which control points are considered CCPs, how are we going to determine what's acceptable, what's not? What's the critical limit for it? Right. So each CCP, there are parameters established to signify if the CCP is in or out of control. And so that's what you determine as the critical limit. The critical limit is the maximum and or minimum value to which a biological, chemical, or physical parameter must be controlled at a CCP to prevent, eliminate, or reduce an acceptable level of the occurrence of a food safety hazard. So, layman's terms, what that means is a critical limit is the minimum and the maximum value that tells you if you're in and or out of bounds when it comes to your control point, your critical control point. The codex definition is the criterion which separates the acceptability or unacceptability of the product that you're running. What's the go no go, right? And so that's what that is. So examples of parameters for the different control points that you're working with. You have temperature, pH, moisture level, line speed, time, and I will talk about those two. Line speed. How can line speed even be a critical limit? We can talk about that a little bit later. Water activity, weight, physical dimensions, sanitizer or water ratio, sanitizer to water ratio, and then the viscosity. So these are some examples of, what you can see on a critical control point to determine whether it is within our limits or not. So for a metal detector, it'll say, yep, it's on and it's functioning, right? So it's on, meaning obviously the product can't go through, metal can't go through without being kicked out. Functioning on says that it detects the metal. Functioning says that it detects the metal and it's going to kick it out such that, it doesn't make it past that point, right? So it needs to be on and functioning. If it's on and it detects the metal, but the device doesn't actually kick it out the way it's supposed to, and that's happened to me in multiple occasions, then it's not functioning properly, which means that essentially it's not working, right? For a screen, it needs to be in place and intact. So not only should it be in place, but you can't have a screen that is allowing product to get past it that shouldn't. So that's what the intact piece part comes from. And then the presence of a supplier guarantee. So not having one or having one. If you see it and there's presence, then it's good. If you don't have it, then you're failing on that critical limit. That's outside of the critical limit there. A critical limit is not an average value. So you have a minimum or maximum value is what we're talking about. You don't have this is an average and so we should be fine. No, if it's outside of that limit, then it's no good. So different examples of not meeting a critical limit may indicate an existence of a direct health hazard. So that's what that means, or direct health hazard could develop potentially further down the line, or product is not produced under the conditions that ensure safety of the consumer. These are all ways that, basically you can potentially harm your consumer if your critical limit is not met. This is what that means. And if that does not mean that, then you need to determine whether or not it's really a critical limit for your critical control point. Setting the different critical limits. So you got the HACCP team determines the standard and the benchmark to be met. And the criteria may be established by regulatory standards and guidelines. For instance, you got action levels, you got performance standards and things of that nature that are very important. However, you have to analyze the entire gambit and understand, what your critical limits are. Once you set those, they can change, but once again, we'll talk about it. We'll always talk about it. We've said it before. We're going to say it again. It's all about documenting that. So once you establish your critical limits, it needs to be documented in more places than one, such that everyone understands what those critical limits are and what the actions are after you are outside of those limits. So examples of regulatory standards or guidelines for critical limits is the maximum allowable concentration for patulin in the apple juice, and the FSIS 7 log reduction of salmonella in cooked poultry. So and the 5 log reduction in the pathogens in juice. I've dealt only with the 7 log reduction in salmonella for cooked poultry. But when we did that, once again, it was a test that we had to do an experiment to determine if we got a 7 log reduction. And if we didn't, then we have to do something to the system, to the oven itself, in order to get that 7 log reduction on a repeated basis. Like, you have to determine, how do you get that 99.9% confidence that you do establish a 7 log reduction? Because if you don't get that, then you haven't proven anything. So how do you set these critical limits? These are multiple ways you do it. We talked about, so you got research, you got scientific publications, you have government guidelines, and consultation with certain experts. We recommend that you develop your critical limits for the type of operation that you're working on. For instance, let's say that you're achieving an internal temperature of 151 degrees for meat patties at 41 seconds. From a product related standpoint, the internal temperature of the product needs to be more than 151 degrees at or more for 41 seconds or more, which means that if you do it for 100, if it's 155 degrees for 46 seconds, then you're still within that limit, right? You still have achieved the minimum standard for that meat patty. So you're still satisfied, you're good. Another way to look at it, as we talked about it before, we talked about line speed as being one of the ways that we can measure this here is, so you got an oven temperature at a belt for, and it needs to be more than 300 degrees Fahrenheit with a belt speed of less than 8 feet per minute. The initial temperature is more than 32 degrees and a patty thickness of less than 15 millimeters, right? So one was product related, the other one was process parameter related. So basically what we're saying is there are a lot of different specifications that you can play with to make sure that you achieve that same standard. And what you would do is you would say, hey, if we look at the product related, we say if we get the product temperature for 151 degrees for more than 41 seconds, what does that look like for our belt speed? What does that look like for our oven temperature? And you essentially set those parameters based off of achieving the 151 degrees at or more than 41 seconds, right? So that's how you achieve your parameters and your standards for your equipment set points. What you'll hear it's basically off of that critical limit that you're held at the, in this case, 151 degrees at 41 seconds at least. So different experiments that have been used to establish the critical limits: heat penetration, temperature distribution, thermal death time studies, inoculated pack or microbial challenge studies, metal detector sensitivity studies. I mean, there's a lot of studies essentially, as you can see, that you do. I've done the temperature distribution and the heat penetration before. Metal detector sensitivity experiments, I don't know if you call it a study, but definitely have done those, worked with the metal detector before. So it's quite a few that you do. But once again, you have to have that confidence level that it's repeatable. If it's not repeatable, then you can't necessarily deem it something to have that to establish and be ready to say, yep, this is the critical limit as a result of this experiment. So one thing we don't want to do is confuse critical limits with operating limits. We need to understand what the difference between those two are. So operating limits may be set for quality or non-safety purposes, usually operational purposes. How do we maximize our output, right? How do we not throw away money? How do we maximize our quality for the product such that, the consumer can't tell what shift this product was made on? This consumer can't tell what facility this product was made on, right? So, that's essentially what this is talking about. It doesn't exceed the limits for safety. with your operating limits, you can't exceed the limits for safety, the critical limits that we were just talking about. We allow for process adjustment. So before the critical limit is exceeded, the operating limits basically are supposed to get you to get to a warning. So you're, maybe a couple sigma standard deviations away from maybe one standard deviation. You're notified, or two standard deviations. You're notified that where you are. One standard deviation away, you're even more notified, right? So as soon as basically the operating limits, if they're working properly, if they're set properly, they should give you a warning of how close you are to your critical limits, such that you don't even exceed those critical limits. You don't even get close to it. So as it says in this last bullet point, the operating limits allow you to avoid the critical limit deviations and the need for corrective actions, which we'll talk about corrective actions a little bit later. I think it's the next section here. So, as we said before, operating limits may be set for quality purposes. They exceed the limits for safety. They compensate for expected variations. They allow process adjustment before the critical limit is violated. They avoid the need for corrective action and holding product. So regulations, they all require essentially the establishment of the critical limits to be met at each CCP. FSIS stipulates that the CLs be designed to ensure that applicable targets, performance standards, and or other agency requirements are met. So maybe they are, a little bit, have more tight stipulations around that, but essentially you just got to know, make sure that you are establishing your critical limits, and it is documented. You got to make sure it's documented. And that's it for critical limits. So looking here at got the chapter review, a critical limit can be an average value, true or false? And the last one is operating limits are within critical limits, or critical limits are within the operating limits. All right, so for number one, the critical limit can be an average value. That is so not true. That's not true. It doesn't happen that way. You have to have a range, a minimum and or maximum value for this, right? And if you outside of that range, then it's no good, no bueno. For number two, operating limits are within the critical limits. Remember, the operating limits allow you to get some kind of warning there to let you know, hey, you're coming close to this critical limit, and if you exceed this limit, guess what? There's some consequences, repercussions, right? AKA corrective actions. When that happens, we need to do something in the system in order to get us back into operating limits, and to make sure the product that was outside of the critical limits, we need to do something with it, right? So that's what the operating limits are for quality, non-safety, but also to give you a warning when you're outside and you're coming pretty close to being outside of and violating the critical limits. All right, so principle number 4 is establishing the monitoring procedures. So what are those? To monitor means to conduct a planned sequence of observations or measurements to assess whether a CCP is under control and to produce an accurate record for future use and verification. Now, that was a lot, but what that means is we just need to conduct observations of measurements. This is a check, a monitor. How are we checking the system? What does it look like? What's the health of the system at this point in time? Every time you monitor the system, you're looking at this point in time. What is it doing today, right now, at this very second? Are we good? Are we not? So what are we monitoring when we say that? Or who are we monitoring? When you say you're monitoring, there are a couple questions that you ask, and this is hit. What is it? So is it the oven, for instance, like we said? Is it the conveyor belt, the conveyor speed, the metal detector? What is it? How are we monitoring it? When are we monitoring it? Is it every hour? Is it twice a shift? Is it every 30 minutes? And lastly, and just as important, who is monitoring it, right? You can't have multiple people monitoring the system for more than one reason. One of them being that, when it's everybody's responsibility, is nobody's responsibility. Somebody has to take the lead and understand that it's their job, such that we have the confidence that it gets done on the set frequency, whenever we deem it necessary. So let's take care of the first one first. So what will be monitored? It can be the oven temperature, it can be the time or the belt speed, it can be the product pH, right? It can be certain things. So the critical limit and monitoring activity must be suited to each other. So the monitoring activity and the critical limit, they have to go together. For example, chicken temperature versus oven temperature and belt speed, right? So once again, you need to make sure that the oven temperature and the belt speed is directly relating to the chicken temperature, right? So if I have my oven temperature and my belt speed at 300, let's say I got my oven temperature at 300 degrees Fahrenheit, I got my belt speed at 2. I don't know what 2 means, but maybe it's something, right? So you got the belt speed at 2, and that translates to a certain chicken temperature for a certain period of time, right? And so once we understand what that translation is, that'll let us know, yep, this is our critical limit, and if we go outside of this critical limit, no bueno, right? So second piece is how would it be monitored? So you have measurements, for example, pH, time, temperature, water activity, etc. And then you have observations. So is the screen intact or in place? Is the ingredient added? Etc. Right? So note here that monitoring activities must provide a real-time assessment of the status of the CCP. Remember, I was telling you, in that point in time, at that moment, what is the assessment? What is the status of this CCP? So when will it be monitored? There are multiple ways to monitor. Continuous is preferred, but it's usually not realistic unless you're talking about it being monitored on or by a computer of some sort. Discontinuous is periodic, like the metal detectors. You check it once every shift, twice a shift, once every hour, that kind of thing. So there's certain considerations for monitoring, and you talk about periodic monitoring. The interval must be short enough to detect possible deviations. What does that mean? I don't want to check my metal detector once a day, because if I run 3 shifts, that's 24 hours. If I check it once a day, then it's going to cover me for that day. But let's say I check it today at 8 o'clock a.m., right? And it works. It works fine. Works perfect. But tomorrow I check it at 8 a.m. and it doesn't work. What do I do then? Well, the last time I confirmed that it worked was 8 a.m. the previous day, which is 24 hours before. That means that I have potentially 24 hours worth of product run that is at risk, that may not have, because I don't know when that metal detector stopped working. So that's what this interval is talking about. The interval must be short enough to detect the possible deviation. Frequency. The frequency should not be overly burdensome. So while I don't want to check it on once a day, I also don't want to check it once every 5 minutes, because it takes 3 minutes to check it. That means I'll never do any work, and it also probably is overkill, right? So that's the frequency has to make sense, and being too frequent doesn't make sense all the time. Consider the amount of variability within the parameter. So that means, and less about probably the metal detector, but there's certain variability within that parameter that you can go, and you don't want to be super, super exact, because then if that min and max value is too small, then you'll be outside of that critical limit unnecessarily too often. Consider how close the operating parameter is to the CL. So that's kind of the same thing, right? You don't want the operating parameters to be so close to the critical limit that once you move even a smidgen on one side or the other, you're now outside of your critical limit. Then you're going to have product on hold every, twice a day, 3 times a day, and then eventually potentially release it, because if it's really outside of that, that standard, the critical limit, and for good reason, then you just don't have a good system running, right? If you got to put product on hold and throw it away 2 or 3 times a day, then you just don't have a good system, a good holding your system. You need to change something at the foundational level, such that you're not running into these issues. Consider how much product you're willing to sacrifice. So once I said it again, so when it comes to critical limits, if you're outside of your critical limit, what does that mean? It means certain different things for different hazards. If it's salmonella, you're probably going to just throw the product away. If it's a metal detector issue, for instance, there's a potential that you can rerun this product through a different metal detector because you were outside your limits, or, something else, right? What I'm trying to say is, depending on the hazard determines what you can do with that product. And depending on what you can do with that product, that kind of determines how much product you want to sacrifice as a result. When you are essentially out, when you end up outside of your critical limit, is that a day's worth of product, which hopefully is not. Maybe it's like 5 minutes worth of product. Maybe it's one batch of product. But considering how much is very important as well. All right, so when will it be monitored? It's important to conduct the monitoring activities at least as frequently as specified in the HACCP plan. So you determine what the frequency should be by the HACCP plan. But once you do that, you need to make sure that you're monitoring at least as frequent as what it states in the HACCP plan. Case in point, if it says in the HACCP plan that I need to check my metal detector twice a shift, then I can't check it once a shift and be okay. But I can check it 3 times a shift. I just checked it 1 extra time. That's okay, because not only did I meet the expectations, but I exceeded them. Missing a monitoring activity can have the same consequence as not meeting a critical limit. So let's say you are within critical limits of running, but you just miss the monitoring activity. Once again, it was supposed to be twice a shift. I only did it once a shift. Well, I don't know what to do with this product that I didn't check it for, right? I got to go back to the last good check. And so that's what that states. Who will perform the monitoring? So we have to designate people. Once again, if it's everybody's responsibility, then it's nobody's responsibility, because people need some type of accountability, and to make sure that we're getting it done on a frequent basis, on the frequency that was deemed in the HACCP plan. So we got to designate in the HACCP plan who will be responsible for monitoring the CCPs, and that's just it. Adequately train that person to perform it, and then also have a backup with the records, because if you don't have the personnel to perform it and they're not documenting it, once again, didn't document it, didn't happen, and that person that is the head or the lead responsible for monitoring this particular CCP, if they're on vacation, they on medical leave, whatever the case may be, you need to still run this system. So every CCP that needs to be monitored, you have to have a backup in order to take that person's place. So for example, let's look at the screen. What is monitored? The intact is the. So for example, let's look at the screen. So what is monitored? You got the screen, and you got to make sure it is intact. If it's intact, we're good. How is it monitored? Well, it's monitored visually. You need to look at it. If it's there, no issues, it's not, fraying or anything like that, causing issues, then we're good. When is it monitored? At startup and at the end of operation. Okay, that works. Who's monitoring it? The production employee. So that doesn't mean that the supervisor can't look at it, but documenting it and on the HACCP plan and through the training, we need to make sure that the production employee and a backup can do it. So there are regulatory requirements that come along with this that basically require the HACCP plans to list the monitoring procedures and frequencies for each CCP that ensures the compliance with the critical limits that we've established for each CCP. Excuse me. Monitoring records must be prepared as well when the monitoring activity occurs. So every monitoring activity has to come along with it, and someone has to document and sign at that particular date and time when they check the CCP to say that it's working properly or it's not working properly. Records subject to record keeping requirements, which is another section in the HACCP plan that is all about record keeping, but this is part of it here. Whether it works or not, doesn't matter. We got to document it. Looking at the chapter review, we'll take the example of the screen. So if I look at the screen, what is monitored? Is it the production employee? Am I monitoring the production employee or the screen? Second one is, how is it monitored? Visually or electronically? The third question is, when is it monitored? At startup or at the end of operation? And lastly, who monitors it? Is it the production employee or the team leader? All right, so the screen is intact. That is what we're monitoring. We're monitoring the screen, not the production employee. We can talk about that a little bit later, but if you're monitoring the production employee, then you're doing something different. You're not monitoring the system. You're pretty much doing a verification that they are performing their work the way that they should. That is an important piece, but it's not included in the monitoring section of HACCP. How is it monitored? We monitor it visually. You can't electronically look at a screen. Maybe you can, but most of the screens that you work with in the food industry, when you're dealing with product ingredients and stuff like that, you're visually monitoring that screen to make sure that it is there in place and intact. When is it monitored? So this can vary, but in that particular case, it's at startup and at the end of operation. Sometimes it's after every dump or before and after every dump. Maybe you monitor them before the dump. Okay, cool, we're good. Then you document it, then you dump. Or I've seen it times where you dump the ingredients into the hopper and then you monitor it. Then you take a look at it. Okay, we're good. All right, well, document it, right? So who monitors it? The production employee or the team leader? Well, the production employee monitors it. Doesn't mean that the team leader can't, but on record in the HACCP plan, on a regular basis at a set frequency, the production employee is doing that.